In this video, I'm going to be going over how to find a conditional distribution from a joint distribution of a distribution that's continuous. So a conditional distribution is actually comes from the Bayes theorem, which is something you learn pretty early on in your statistical career. A quick review of that is the probability of A given B is equal to the probability of A and B over the probability of B. And we can actually use this theorem to find our conditional distribution. So, for instance, if we wanted to define f of x1 given f of x2, we would use the joint distribution on the top, f of x1, f of x2, divided by the marginal distribution that is of interest. So in this case, it would be f of x2. This problem all of a sudden doesn't look so daunting. We already have the top part, we just need the bottom. And we can get this bottom part, the marginal distribution of x2, by from the joint distribution. We can do this by integrating over f of x1. So we know the bounds of f of x1 are x2 and 0. And we will go over the joint distribution, which is 2, with respect to x1. We then get 2x1 from 0 to x2, which is equal to 2x2. Now it's really important that this is a distribution, so we got to remember our bounds, and this is for all possible values of x2. Bounds are really important just in general, and it's really important to pay attention to them when doing these types of problems, since we're bouncing around a lot. So the bounds for the marginal distribution of f of x2 is all possible values of f of x2. And in this case, we're no longer considering f of x1 at all, so we can get rid of that part up here. So now we want to find the conditional distribution. F of x1 given f of x2. And this will be 2, which is our joint up here, divided by 2x2, which simplifies to 1 over x2. And we cannot forget our bounds of the distribution. And in this case, it's actually 0 to x1 to x2 to 1 and 0 otherwise. You can write otherwise elsewhere, same thing. Now you may be asking yourself, wait, there is no x1 in this conditional distribution. Why are we including x1 in part of the bounds? This is just good practice. Conditional distributions, just the distributions, could be defined in both terms. So it's good practice to remember to include both in your bounds. And that's it for this video.